In this video we're going to be looking at working with binary data in Node and Node-RED. Now, data stored on computers and transferred between computers on computer networks is stored and sent as a sequence of bytes. Now, a byte is 8 bits of data, so data read from a file is read in bytes, written to a file is written in bytes, read from a network connection is read in bytes, and written to a network connection is written in bytes. So bytes is the basic unit we'll be dealing with, or a byte is the basic unit we'll be dealing with. Now, when storing and transmitting data, you'll need to represent various types of data. We'll need to represent characters and numbers, e.g. A, B, C, D, 1, 2, 3. We'll need to represent integers, both signed and unsigned integers, long and short integers. Now, the size of those integers is machine dependent and operating system dependent. Floating point numbers, both single and double precision floating point numbers, Boolean values, true and false. So we need a way of encoding that information as a series of bytes. So if we start with characters, they're probably the simplest to understand. How does a computer store the letter A or the number 1? Well, to store it, it needs a coding scheme, and the common schemes used today are ASCII and UTF-8. Now, ASCII was the original scheme in use. It was the original scheme when I first started working with computers. It's restricted to the English language only, i.e. it doesn't support foreign languages, and it uses a 1 byte to 1 character. Now, there are various ASCII extensions that were implemented to support foreign languages, the European languages, French and German, but that's all been replaced now by UTF-8. That's the common encoding scheme used on the internet, and that uses a 1 to 4 byte scheme. So you can have a character can be 1 byte, or it can be 2 bytes, or it can be 3 bytes, or it can actually be 4 bytes. Now, that works with foreign languages. It also works with icons, smileys and things like that. It is fully backwards compatible with ASCII, so an English character or English language character encoded as UTF-8 will look exactly the same as one encoded as ASCII. When data is read from a file or network, it's read byte by byte into a data buffer. Now, a data buffer is simply a temporary storage area used for transferring data. But to work with binary data, we'll actually need access to these buffers. In Node-RED and Node.js, we'll be using the Node.js buffer module to access those data buffers. And you'll find a good reference to this module on the W3 Schools page. And here's the URL here. This is W3 Schools website, and this is the Node.js buffer module. Now, this is a very good guide to the buffer module, and I'll be using this throughout the video. And as I say, I'd recommend you go to this URL and take a look at it. And it starts out with creating a buffer, and we're going to go through various different methods of creating buffers, and this one is using a string. I'm going to first start out with some PowerPoint slides on creating buffers, and then we're going to move on to the command line. Now, the PowerPoint slides are created using the command line. So here we are. First thing we're going to do is create a buffer from a string. So there's the string ABCDE, and we use the buffer from method of the buffer object, and this is the buffer, and these are hexadecimal. This is the way it's stored on the actual computer. So that's creating a buffer from a string. We can also create a buffer from an array of numbers, so 1, 2, 3, 4, and this is what the buffer looks like when we do it. 1, 2, 3, 4. Now, these are actually hexadecimal. If I were to look at this in binary, I'd see 0, 0, 0, 1, etc. Now, there is a difference between numbers, pure numbers, and numbers represented as characters or strings. And when you type in onto a keyboard, you're typing in characters, and those characters actually get stored on the computer using encoding, and the encoding is normally ASCII or UTF-8, and we'll look at that in a minute on character encoding. But this is the buffer again, created from an array of numbers. Now, it's treating these as numbers rather than characters, so it's doing the conversion, and it stores them as 1, 2, 3, 4. So 001, 0010, etc. if it was in binary. And this is the buffer again created using a string of characters. This time the string is 1, 2, 3, 4, and you can see they're stored as 31, 32, 33, 34, and that is the UTF-8 or the ASCII representation of those numbers. So 1 is stored as 31, 2 is stored as 32, and 3 is stored as 33. So if we wanted to convert them to numbers internally, we'd have to do a conversion to convert it into actually a pure number, which is 0, 1, 0, 2, and 0, 3, and 0, 4. So here's another way of creating a buffer, and this one is using the alloc method, and we're going to create an empty buffer of 10 bytes, and you just use buffer.allocate and the number of bytes you want, and this actually creates a buffer and initializes the buffer to an empty buffer, which is all zeros. So let's look at now working with characters, and we looked at that previously when we saw the number 1 as a character and how it was stored internally. Now remember back to an earlier slide, UTF-8 uses 1 to 4 bytes to encode a character, and ASCII uses 1 byte. Now most computers today default to the UTF-8 character set and not the ASCII character set, but you should remember that for English characters the representation is exactly the same in ASCII as it is in UTF-8. So the character A looks the same when you encode it as ASCII as when you encode it as UTF-8. We're going to use the command line to look in more detail on string buffers and character encoding, and we're going to look at the ASCII character encoding and the UTF-8 character encoding, and how we encode foreign language characters. So here we are at the node command line, and I've just created a buffer from the string A, B, C, D, E, and this is UTF-8. It's encoding, and it's UTF-8 by default. I can specify the encoding using and that's ASCII encoding, and it's exactly the same. So UTF-8 and ASCII encode English characters exactly the same way, 1 byte for 1 character. So the character A is represented as hexadecimal 61, and that's the way it's stored on the computer. Now it's interesting when we look at foreign language characters. So this time we're going to encode a foreign language E. We're going to use the French E, and to do that I'm going to use the Windows 10 keyboard, and I'll show you this because I only found about this the other week when I was preparing for this video, and it's down here. You might need to actually enable it, and if we just click on the E, you can see it opens up and it gives us different options for the E, and this time we're going to select E graph, or sorry, it's E acute, isn't it? And it's given me 2 of them. I just delete one of them. So we got the French E there, E acute, and if we convert that, you can see here this time we've actually got 1, 2, 3, 4, 5, 6 bytes, but we've only got 5 characters. So this E acute is represented in UTF-8 as C3A9, so it uses 2 bytes to represent that. Now if we did the same, but this time we encode it as ASCII, and you can see here this time we've got 5 bytes. We've got E9 instead of E to represent the E acute. And if you look at the ASCII table, this is the ASCII question mark, and it can't encode this. It doesn't know about the E acute, and so it just substitutes a question mark for that. Just as an aside, if you haven't got the keyboard displayed on the menu bar down here, if you click on English, right click on here, this is the language option, the keyboard option, and you enable the touch keyboard button, and it appears down here. You can see it then, and that's what gives you access to this keyboard. This keyboard is what you'd find in a mobile phone, and it allows you to put foreign language characters in. It also allows you to put other things in there, like smileys and things like that. Very, very useful. As I say, I only found out about this a few weeks ago. So we've created buffers from strings, so now we're going to do the opposite. We're going to take a buffer and we're going to interpret it as a string. And to do that, we're going to use this method, and I'm again at the W3 Schools site. Took me a little while to find it. Here we are. We're going to use the toString method. So let's go back to our command line, and we've got our buffer B. Let's just type it in, and this is the ASCII one we created earlier. And so if we just go and you can see here, this is what it looks like as a string. So if we go back and we just do the French with the French Encoding, and we do exactly the same, we convert that to a string, and this is what it looks like here. We got back our Encoding there. And we see this when we go and look at the Node-RED flow. We use the same methods in our functions in Node-RED as I'm using here on the command line. So let's move on to Node-RED, and we'll have a look at a flow that uses this method, the toString method, and we'll have a look at a flow that takes data in from a file, and we're looking at taking it in as UTF-8 characters, so the system does the encoding for us, or we take it in as raw binary data, in which case we may need to do the conversion ourselves. So here's our Node-RED flow, and what we're going to be doing is we're going to be reading in data from two files. One is called test.txt and the other one is called text-bomb.txt, and bomb stands for byte order mark, and we'll look at that in a second. But essentially these files are exactly the same, and I'll show you them now. This is the test-bomb.txt, and it just contains the word hello, and this is the test.txt, and again same text, hello. Okay, so the first one here, we read it in as a single UTF-8 string. The options here are one message per line. We've only got one line, so it makes no difference. And next option is a single buffer object. So if it was a 1 gig file, it would try to read in 1 gigs all in one go, or a stream of buffers, in which case it would actually read in chunks of the file and pass them on. Okay, so we're going to read this in as a text file, so we inject, and we can see the word hello. So it's actually read the data from the file, converted it in the background into UTF-8, and that's the result there. So if we read next time, this time we read it as a buffer, as a single buffer object, and do an inject, and you can see here that's the decimal equivalent of that buffer. So let's move on to the test-bomb.txt, and if this is reading again as a text file, and we just do inject, and you can see we finish up with hello. It looks exactly the same as the other one, and now we read it in as raw data, as a buffer object, and this time we see something different, and it's over here. Let's just drag this over so we can read it. And we can compare it here now. The 1, 2, 3, 4, 5. These are the starting at 104. These are the words hello, but we've got 3 bytes before it. Now this is the byte order mark. Now this is because on Windows in Notepad, if you save a file as UTF-8, it puts a byte order mark in front of it. And let's just do a wiki on byte order mark. Okay, this is what Wiki has to say about it, and It does vary depending on the character encoding you're using, and I'm not going to read this out to you. You can read it from the screen yourself. And they said it's actually optional. You don't find it on Linux systems. You do find it on Windows systems. The Notepad, say, puts it there automatically when you save it as UTF-8. And you should notice when we read it in Node-RED using UTF-8, the Node-RED strips it out anyway, so you don't actually see it. Why I pointed it out is if you are reading in raw data and raw text data, there might be a byte order mark there. So if it's not UTF-8 encoding, then you might need to strip that byte order mark out before you process the data. Okay, so that's enough about the byte order mark, just to point out that it may be there and you should be aware of it. So let's move on to the last demo here, and here we're just reading in the text file again, and we're reading this time as a single buffer object, and you can remember what it came out with. It came out with that. So what we're going to do now is in our function node, we're going to take this buffer and we're going to convert it to a string. So this is our function. It's very simple. It takes the payload, converts the payload to a string using the toString method which I showed you before, and then it returns the payload. So let's do an inject, and you can see we finished up with the string hello. So instead of letting the system automatically do the conversion, we've done the conversion within the function. So that brings us to the end of this video. It's part one really of a two-part video series, because in the next video I'm going to discuss integers, short and long integers, floats, single and double, and big and little endianness, difficult word to say that actually. And we're going to look at how we store integers and how we store floats and how we actually retrieve integers and floats from buffer objects. So if you've got any comments on the video, then please leave them below. If you like the video, then click the like button below. If you want to get notified of new videos to the channel, then you can always subscribe. And if you do use social media and like to share it, then please feel free. Until next time, bye.